This is the Chapter R Notes for R.4, MAT 111, Algebra 2 at Suffolk Community College. R.4 is properties of real numbers, and we're going to go through the names of those properties. We've already talked about order of operations, how to reviewed most items in this chapter. So the distributive property is when you distribute multiplication or division over addition or subtraction. So you've got a plus or minus inside a set of parentheses, and you basically kind of jump over this set of parentheses that you're supposed to do first, but you can't, because addition and subtraction are very weak and you just can't do it. So it looks something like this. If I have A, B plus C, this becomes AB plus AC. It can look like this. I'm still subtracting. If I subtract it inside, I subtract when it's done. Now what that does is now I can't add A plus C, but I could multiply first, but I've got to multiply by both of them. I want to show you it also can be like this, B plus C over A. Well, that's B over A plus C over A. Or I can do it with a subtraction in the middle there, so I might as well do that. B minus C over A is B over A minus C over A. You cannot cancel one without so I'm sharing. Both of them get it. That's called the distributive property. And it also can be done in reverse. The reverse is also true. So if I have AB plus AC, then what I call this is actually, this is AKA, also known as factoring. I'm going to see a lot of that. We're going to see a lot of that. We can extend it to a string of additions and subtractions inside, or things that get a little complicated. So we're going to use this property when we cannot do what's inside the parentheses. Okay, so basically we can clear the parentheses. You can think of it as doing that. That's what this distribution does. Removing the parentheses or clearing the parentheses. Let's see. That's the distributive property. Kind of a combination of levels 3 and 4, addition and subtraction, a multiplication or division, which is level 3, over addition and subtraction, which is level 4. So let's look at the identity properties, which I've already talked about. And we've got two of them. We've got for addition, A plus 0 equals A, but we could also say the other way around. 0 plus A equals A. So 0 is the additive identity. 0 is the additive identity. Of course, we just use addition, but if I had a subtraction in here, ooh, this one wouldn't work. This one would. Oh, that won't work. It has to do with something else. For multiplication. For multiplication, we know that a number, I'm just going to use a different number, times 1 is that number again, or 1 times that number is that number again. So 1 is the multiplicative identity. So look in the mirror. You know, I'm going to write that down. An identity is a reflection. No, not a reflection. If you look in the mirror, you get back the same image. Look in the mirror test. You get back the same thing. It's an image. So is the identity properties. The inverse properties, we've already discussed. But in general, the inverse properties actually, when doing the operation, when performing the operation, you get back the identity. So again, we've got to look at the different operations. So we've got addition. So if I've got a number and I want to add another number and get back the identity for addition, which is 0, I need to put in its opposite. So for addition, they're opposites. For multiplication, I'll do the B again. For any number, when doing the operation, you get back the identity. So here I want to get back 1. So B times what equals 1? That is its reciprocal, which is 1 over B. B over B will be 1. So these are reciprocals. Now for any operation, when you find the identity, you can then look to see if there's an inverse for each element in there. So I used this word before. Inverses an inverse I didn't spell that right. An inverse undoes the operation. So sometimes we think of, we'll say addition and subtraction are inverse operations. and also multiplication and division, or inverse operations. We don't really have inverse operations. We're really adding an opposite or multiplying a reciprocal. And that's how we defined subtraction, adding an opposite, and division, multiplying by the reciprocal. So that's how we define those. These are different ways, but these are very highly connected, as well as multiplication, division, and you can kind of mix and match the order of multiplying and dividing. That's why we can reduce. And you can mix and match the order of addition, or sometimes this is just combining, recognizing that subtraction is negative signs. That's it. That's it. So we did an inverse property, and let's just talk about the commutative. Oops. The commutative property, commute, move. Think of commute as moving. The commutative property is basically, you know what, no, I'm not going to say that yet. We can say if we've got two real numbers, a plus b is the same as b plus a. That's for addition. And we can also do this for multiplication. A times b equals b times a. The associative property think of this as associate. Associate with first. The associative property, again, addition. If I'm adding three things, I can associate the first two. That should get me the same answer as if I add the second two first. ABC, ABC, no commuting, no moving. Everybody's in the same order, but I'm doing these two first, or I'm doing these. So I'm associate with first, and then I have a third one. Multiplication will look basically the same. A, B, C, A, B, C. This time I'm going to multiply A and B first, and this one I'm going to multiply B and C first. So this is called the associative property of multiplication. This one is called the commutative property of addition. So you need to add which operation you're doing. There is no subtraction. There is no division in this. And that's one of the reasons why when I was going to say A minus 0 equals A, but 0 minus A does not equal A. So you can't just, there is no commutative property for subtraction. That would be a negative A. That's not going to work. Let's see here. So what I wanted to say is together, the commutative property and associative property allow us to say you can add or multiply in any order. Kind of use them together, but you need to understand commutative property is the switching, and the associative property is actually the associating, or what you're going to do first when you have more than more than two elements that you need to do things for. So let's take a look at this. Let's using these properties. Let's do 12b minus 9 plus 4b minus 7b plus 1. So we are going to throw these all together, and we can shift things around, move them around, and put the b's together and the whole numbers together. This is 12 times b and 4 times b and 7 times b. We'd have to do those first if we knew what b was, but we don't know what b is. So let's just throw this together as combine like terms. I know you've heard of this, but let's see what's going on. Combine, I said, was adding and subtracting. Terms and like terms. So what are like terms? They have the same variable piece. So I can do 12b plus 4b minus 7b minus 9 plus 1. So I use the commutative property. But notice when I said I didn't look at this as 4b minus 7b. Well, let me take that back. I didn't look at this as 12b minus 9. I looked at it as a 12b plus a negative 9b. So that negative sign went with the 9. See, I didn't leave this as a subtraction and just move the 9 over here. This is really a negative 9. So you've got to look at these as terms with their sign. And I moved the sign along with them. So this negative 9 moved all the way over here, negative 9. It's not a 9. It's not a subtract 9. It's adding a negative 9. I need you to recognize that sooner rather than later. So these three all have a b in it, a b in the back. So this is why you can actually combine 12 times b plus 4 times b minus 7 times b. Okay, I didn't finish this. Let's just minus 9 plus 1. I'll get to those later. Now I can do what's inside parentheses. So I factored 12 plus 4 is 16 minus 7. Whoa, I don't know if that off the top of my head. Negative 11. 12 minus 7. Okay, this is a minus 3. Yeah, 12 minus 3 is a 9. Okay, I was going the wrong direction. 9b. 16 minus 7. Oh, yeah, right. 16 minus 7. Silly me. So that's a 9. So I've got 9 b's. Negative 9 plus 1 is minus 8. That's your answer. That's your answer. 9b minus 8. And I just saw the answer, so I'm good. Okay, so that's how you work with that. Sometimes when we say combine like terms, we use the commutative property. We use reverse. Here we use reverse distribution. And then or aka factoring. And then from here to here, we used order of operations. Inside the parentheses and outside the parentheses for like terms. These actually have a factor of 1 attached to them, and they'd be inside parentheses also. But you don't need to go through that. And I hope you saw what I just did. We only have a few more properties, and that is oh, what is this? Here's another example. What is this? Well, when you see parentheses, first off, this is multiplication, multiplication. So the parentheses kind of just complicate things. I can get rid of the parentheses because 3 times x is also a parenthesis, times 5 times y. Do not be distributing. This is not addition, subtraction. You cannot distribute over that. So if you did, you'd have an extra 3x term, and you don't. So these two guys can be multiplied together to get 15, but the x and y have nobody to multiply with, so that's just x and y. So that's the answer for that question. Be careful, do not distribute. Wanted to point that out. And lastly, the multiplication property of 0. So if I take a number times 0, or 0 times any number, what do you get? 0. It wipes it out. Wipes it out. It's the bomb. So let's just go back to why can't we divide by 0? Why can't we divide by 0? Well, if I have 3 times 5 equals 15, that gives me 2 facts. This is called a fact family. We know that multiplication is related to division. I'm going to write it like this. 15 divided by 3 is going to equal 5. And 15 divided by 5 is going to equal 3. Now, since I've got this equals here, the left side equals the right side. 15 divided by 5 equals 3. So if I go and do this, this is for any pair of numbers that multiply together. I can turn it into a division problem. So if a times 0 equals 0, then 0 divided by a equals 0, and 0 divided by 0 equals a. Let me not use an a. Let me use 5. I'll just use a, it doesn't matter what we use. 5. I'll turn this into a 5. I should turn into something I could turn into. It's going to be a 5, and this one's going to be a 5, right? I said this one was okay. This is 0 divided by 0 equals 5. Well, if 7 times 0 also equals 0, then that would mean that 0 over 0 equals 7. But we already said it equals 5. So that doesn't make sense. So let's say 10 divided by 0. What is 10 divided by 0? Let's say it equals 0. That means 0 times 0 equals 10. So 0 times 0 equals 10. That doesn't make any sense. Well, let's say 10 divided by 0 equals 10. That would mean that 0 times 10 equals 10, and that's not true either. So we've got an issue when we divide by 0. I'm not sure how much of that you could see. We can discuss it more in class if you want. But basically what it comes down to, dividing by 0 gives you a problem. These two things they conflict. So in math we just say you cannot divide by 0. No, n over number over 0 is undefined. No. And that's it for chapter R.4 and chapter R.